This is Geometry, Unit 7, quiz number 1. It's day 5. You'll need your packet with these examples because I'm just not going to be able to reproduce every image that you have to work with. So please make sure you have it with you. I have a circle here, but many of your examples will have much more than just that. But I'll do my best with what I have. All right, so number 1, you have a figure. It's a circle, and what we can do is, it basically looks like this. I'll just draw another circle for this example. We have these lines are tangent, and then they intersect at point P. And that B is a point of tangency, and A is also a point of tangency. And you have another line that's going through right there, and it bisects the angle. And it's also going through the center of the circle. And so we want to find the measure of angle BPO. So that's this one. O is right here. It's the center of a circle. So we need to find that angle given that angle AOC is 64 degrees. So if we have, those are right angles right with the tangents. Remember, tangents form right angles with the radius. And we have angle AOC given as 64, and that's right here. AOC is this point where it intersects the circle. So that angle is 64. Alright, so it wants us to find BPO, which is right here. Now, we know this is a right triangle here, so that angle is 90 degrees right here and right here. We also know that this angle is bisected here. So these two angles are the same, but also these angles right in here are the same. They're both going to be 64. So you have a triangle with angle 64, 90 degrees, and now we just have to find that third one right there. Well, the total of angles in the triangle is 180. So we can subtract from 180 minus 90 minus 64, and that's going to give us 26 degrees. Is that angle BPO. Number 2, we have a triangle circumscribed about a circle. It kind of looks like that. It's going to be a little different. In your packet, all the sides should be tangent. Alright, so basically we're given this, and we're given some of the measures here. JK, KL, and LG are all tangent to O. JA is 14, so this one's 14 right here. CK is given as 10. Well, we just label the information that it says AL is 7, and that's here. So we just have to find the perimeter of the triangle. Well, you know that for 1 point, if the lines are tangent at the circle for both lines, then the distance is going to be the same. So this line is equal to that one, so that's 7. This one is equal to that one, so that's 10, and then 14 is the rest. So now you just have to add them all up, and you'll get 62, and that's it. Number 3, we have, we circled O, and we also have, this is going to be drawn to scale, we need to find that measure of angle O, so we need to find this right here. And it's 144 degrees. Now, since these are right angles, we have a quadrilateral, of these 4 angles, and we know 3 of them. So if you have a quadrilateral and you know 3 angles, you can find the 4th. And a quadrilateral, the angles are going to add up all to 360 because there are 4 sides. So 360 minus 144, and then minus 2 90-degree angles, which is 180. And so you just have to subtract it, and you get 36, and that's your answer. That's the angle right there. And number 4, we have a tangent line right there, AB. We have circle O is in the center. A line connecting those two. And this is a right angle because it's tangent. That's their radius. AB, they give us 9, and AO is 11.3. So we just need to find that radius length. So this is a right triangle. So we have r squared plus 9 squared equals 11.3 squared. Because it's a right triangle, you just use the Pythagorean theorem. So you just have to work it out, and you're going to end up with the radius is 6.8. Number 5, let's see, center C, line goes through there, W, Z, you have R and X, these are diameters. You also have point Y, and this angle is 69, and this angle is 38. And it says find the measure of arc ZWX. So we want to find what this measure is right there. Well, you know that ZW, since this is the diameter here, you know that that arc must be 180. So ZW is 180. It's half the circle, it's the diameter. So you know it must be 180, and then all you have is this one right here, which is 38 degrees with that central angle. So you just add them together and you get 218. Number 6, find the value of x. We have a chord, which is 15. We have a center, which is 8. We have a little segment coming down that's perpendicular. And we want to find radius x given that information. Now, a line that's from the center that is perpendicular to a chord bisects that chord. So we know that that's 7.5 and that that's 7.5. Now if we draw a line from the center to the end point of the segment of the chord, it's going to form a right triangle, and here we have 2 sides of the right triangle. So we can say 8 squared plus 7.5 squared equals this. Now this is a radius just like this is. So this is x as well. So that's a hypotenuse is really what the radius is. So when you work that out, you're going to get x squared equals, let's see, I already know that. So x is going to equal the square root of 64 plus 7.5 squared. And you just work that out, and you're going to end up with x equals square root of 120.25. And so x is approximately 11. For 7, you have diameter AB, so it goes through the center. You have point C and D, which make a chord. That's perpendicular right there. And you have some angles in there. Angle CBD is given as 57, so this whole angle is 57. Alright. So what can you do here? Well, there's a theorem that when you have an inscribed angle and its endpoints are at the endpoints of a diameter, then that angle is a right angle. So you have a right angle there and a right angle there. Since the endpoint's there, since the segment is perpendicular to the diameter, then it bisects this angle here. So each side of that is 28.5. So basically, you have two angles of a triangle. So there's 90 degrees supplementary to this angle, and so you can easily find this one as 61.5. And then, since these two angles here are complementary, they form right angles, then you can find it by subtracting from 90, which will give you 28.5 here. And since this is another right triangle, you have 90, 28.5, and that angle is going to be 61.5, which is your answer. Number 8, you got a diameter. You have two inscribed angles, which are right angles, and it gives you BDC. This is BDC is 57. What is the measure of arc CAD, which goes around there? What is the measure of that entire arc? So basically we're taking this and we're subtracting this arc from the total of 360 degrees. So it's going to, what's the measure of that arc right here? That's what we need to know. Well, we have a right triangle here. We have 90 degrees, 57, and we can find the third angle, right? It's 33. We know that an angle inscribed, interior angle, is going to be half of the measure of the arc. So when you have an angle inscribed like that on the outside of the circle, you can simply subtract and get the difference between 180, since you have the other angles here. So what's double 33 is 66, and I just have to subtract that from 360. And I get 294, and that's my answer. The last one is number 9, measure of BAC. I know it's diameter because it goes through the center with endpoints on the circle. My point B is there. And this is what I want. I want to find the measure of BAC. So it's this angle right there. I'm given that this is 54. And since that is a central angle, my arc is also 54 right there. Now, if it's an angle that's on the side of the circle, then it's going to be half of its inscribed arc, half of its intercepted arc, excuse me. Well, you can see that central angle is equal to the arc, and this angle is going to be half of that. So what's 1/2 times 54, or 54 divided by 2, and you get 27, and that's your answer. So it's a lot, it looks more complicated than it is. And that's the end of your Day 5 quiz.